computer. Good evening, everyone. This is Shauna, and I'm coming to you again with another homework walkthrough video. This one is going to be for section 4.1, but I'm not going to cover the whole section in this video. There's too much content. There's too many sample spaces to go over. So in this video, I'm hoping to cover up to the first 10 problems and some of the terminology that you'll need to know to continue with some of the work. Section 4.1 is very foundational to the rest of the chapter. And it's not like the other chapters in the book. Chapter 4 is kind of the odd turning point in the book. We've talked about data analysis. Then we're going to talk about something called probability in chapter 4. And then in chapter 5, we're going to talk about distributions. We're going to start talking about distributions in chapters 5 and 6. Then we're going to connect those two concepts, the distributions with the probability, for later work that we're going to be doing in the book. So this is kind of the odd chapter out. So let's see what we can do here. Let me get started. Okay, so I'm going to pull up the homework assignment. And as usual, it starts with some basic questions from the slides, but I am going to go over these, which I usually don't do in a great deal of detail. But what is a probability experiment? What is the difference between an outcome and an event? And what is the range of the values of the probability of an event? So we'll get to that. All right, let me now do something here. I'm going to stop sharing the screen for some time here. Let me remove some of my captions and go to my PowerPoints for a minute. Okay, let's see. Where are my PowerPoints? Where would I be? Just bear with me for a moment, folks. Okay. It's going to be open. And I'm going to look for 4.1. When we're talking in this chapter about probability outcomes, we're talking about random chance. So we're talking about things like rolling a die, rolling a pair of dice, working with cards, that sort of thing. So we're going to be talking about doing what we call an experiment. And that usually means undertaking some sort of activity where you have a chance of something happening. It could be pulling a card out of a deck. It could be spinning a spinning wheel. Could be doing something with two dice. Okay, we're going to talk about that in this chapter. So here are the PowerPoints. Let me share the screen here and show you what we have going on. So probability and counting rules is what the whole chapter is on. Chapter 4.1 is on sample spaces and probability. We'll have more to say about what sample spaces are shortly. This chart shows up in chapter 4 and stays here throughout the rest of the chapter. This gets very important in chapter 6 and on, but particularly in chapter 8. So this is here as a reference for you. The math symbol is above the wording. So this is about having to translate your your English statements into math. This symbol is greater than, this symbol is less than, the middle one. And then of course the equal sign and all of the phrases that mean equal. So you can peruse that at your leisure. It will be there for you, as I said, in every lesson. We have less than or equal to from left to right, greater than or equal to, and not equal to. Okay. Now, here's the first question. It said, what is a probability experiment? Here it is. A probability experiment is a process that leads to well-defined results called outcomes. So it's a process of doing something, but it's a chance process, okay? Meaning that we don't know how it turns out. So it could be, as I said, a spinner that you spin. It could be a coin toss. It could be a single die. These are some examples, as I was saying. Now, the possible results, because remember, for sometimes we get, there's usually more than one possible result. Sometimes there's more than one possible result at a time. Sometimes there's only one result possible at a time, but those results are called outcomes. So for example, okay, my probability experiment is my process, okay? So, and that helps to define this. So I'm going to show you something here that I hope will clarify. So let's say that I say this, okay? So remember, a probability experiment is a process that leads to outcomes, right? So if we go back, it's a probability experiment that it's a process that leads to specific outcomes, okay? So let me come back to I need to move this down here so I can see, and I need to change this. Here's our slide, okay? A probability experiment is a process that leads to well-defined results called outcomes. The results are the outcomes, okay? Process that leads to well-defined results. So here you would say a probability experiment is a process that leads to you can write that in your definition. Well-defined results, defined results called outcomes. Now, that's question 1. Okay, so the process is the experiment. So let's say, here's my example. Let's say that my example is roll a single die. That's the process, rolling a single die. That's my experiment, okay? So the example here, the process is roll a single die, okay? It could be roll a single die 10 times, roll a single die once, roll a single, whatever it is, but the process is rolling a single die, okay? Now, the outcomes of that process, okay? Now, if you have a single die, and we're talking about a standard die in the US, the outcomes on a standard die, provided that it's fair and not loaded, are 1, 2, 3, 4, 5, or 6. I'm sure most of you, if not all of you, have had the process, have engaged in the process of rolling a single die, probably 2 die or maybe more. If you've ever played a board game, you've probably rolled a die of some sort. By the way, just a little aside here, in case this is confusing for some of you, we have 1 die, one cube, one little cube, that's known as a die, okay? This is a die, so you'll see that. If it's 2 cubes or more, those are called dice, D-I-C-E. So it's just an irregular plural, if that's not familiar to you. But one of them is called a die, 2 or more are called dice. Anyway, the outcomes are 1, 2, 3, 4, 5, 6. Now, that obviously, if you roll the die, you're only going to get a single outcome each time you roll the die, right? So this is your possible outcomes. So if I roll a die here, let me see if I can do something. Let me stop sharing the screen. And let me show you this. Let me go to roll. Okay, so here I have, let me share the screen one more time. Here, well, actually, probably many times, but right now, let me share this. Okay. Here's my die roller. We're gonna roll our die. You rolled 1 die, we got a 3, okay? That's 1 roll and our outcome is a 3. Let's do it again. This time we got a 6. This is my outcome. This is a 6, okay? Every time you roll a single die, you get 1 outcome, okay? Now, we're getting a little, not too much, but I don't want to get too far ahead of ourselves. But here, the list of all possible outcomes, these are possible, right? So if you remember what we did, okay, we rolled, so we did this experiment, right? We just carried out this experiment, this process twice, okay? So we rolled a die twice, or actually we rolled a die. And let's say that on the first roll, we would say that our first roll, the outcome was roll a 3. Okay. Then we rolled the die another time. We performed the experiment again. We rolled the die, and on the second roll, the outcome was roll a 6. We got a 6, okay? The outcome was we rolled a 6. We're going to talk about how to come up with the probabilities, what we do with that later. But this is the difference between an experiment and an outcome. Now, the next thing we need to be aware of is it says, let's go over here. We wanted to know what is the difference between, so we talked about an experiment. That's this. Let's go on. This is the next thing here. Let me continue on the slides. Now, a trial means flipping a coin once, rolling a die once, etc. So what you just saw me do were actually two trials of rolling a single die, okay? We rolled a die. Now, we have possible outcomes for that. Now, here's the thing, okay? I could roll a die a bunch of times. Now, we're trying to distinguish here between the outcome that you actually get and the outcomes that are possible to get. So let's continue here with something. My experiment is to roll one die, and I'm going to, for the sake of being consistent, roll one die 2 times. That's our experiment, okay? Now, the outcomes that I got, were as follows. First roll, I rolled a 3. Second roll, I rolled a 6, okay? These are my outcomes. Now, those are not the only outcomes possible. Every time I roll a die, again, provided that it's fair, all right, I have a possibility of any of 6 outcomes. So the sample space, and this question comes up later in your homework, not too long from now, the sample space is a list of all possible outcomes for an experiment, for a probability experiment, okay? So when you saw me doing this over here, when you saw me writing outcomes, I probably should add the word possible outcomes to that, okay? These are possible outcomes. So this actually is the sample space. And we normally, when we write the sample space, we write it in braces. What I'm going to do here is I'm going to once again switch gears and go to, okay, let me stop sharing for a minute so I can get us the slides back. Give me a moment to do so. All right, so we have and let me also, while I'm here, pull up the homework section that we were looking at. This is homework. All right, so what is the difference between an outcome and an event? Okay, well, because we talk about the probability of an event versus an outcome. So what is the difference here? Now, I've already talked about what an outcome means. Okay, an outcome is the result of a single trial, but an event can consist of more than one outcome. And this will be more apparent to you when we start getting into problems. So here, the second question here let me come back to you. So, going to share the screen here. And we're going to talk about this now. So we've talked about outcomes. We haven't talked about an event all that much, but we're going to right now so I can help you with some of this. All right, so let's go back to our role. Here's our experiment, all right? And remember, that's the process of engaging in an activity that has more than one outcome. So this is a process, okay? So this is the process of rolling a die, right? That's an experiment. Now, the outcome is what actually happens, okay? And so we know what the outcome was for us. Roll 1 was a 3, roll 2 was a 6, right? So that was our outcome. That's the result of a probability experiment. Now, an event is different from an outcome. Here's why, okay? Because an event doesn't have to, but it may consist of more than one outcome. Let me show you what I mean. If I said, so this is the answer to what is the difference between an outcome and an event, which is the second question on your homework, okay? Now, if I say, find the probability that if, and I'll talk about how to compute probability in a minute. We're not quite there yet. Don't worry about this. I just want you to see how this would be worded. Find the probability that if you roll a die twice, both outcomes will be odd. Now, we really don't have enough knowledge of probability in this section to answer this question. I'll tell you what it would be, but you're going to learn later how to find this. This is an event. So we would write, let E for event be rolling 2 odd numbers on 2 rolls of a single die, okay? This is what we call an event, okay? Has 2 outcomes in there. I could say, and this we will be able to, this we have to do later. This probability, by the way, is going to be 1 out of 4, okay? But we'll come back to why. We won't know how to answer this for a minute. I just want you to know what an event is. Another way to get an event that you'll see in this section is something like this. You'll have something like a spinner. You'll have a spinner or a circle, right? You'll have a spinner and you'll You'll use the spinner, right? I'm not going to actually do this. I'm just going to kind of dramatize this. There's my spinner, right? And you'll have a spinner and you'll roll a die. That's an event. What is the probability that your spinner lands on red, say, and your die is an odd number? That's an event, okay? So now when you have probabilities, let me go back to the next part of this question, okay? Because a lot of these questions actually are straightforward. One of the things you need to understand, though, about probability is that it has some limitations. I'm going to come back to the deck of cards and the dice sample spaces that you see on slides 7, 8, and 9, 7 and 8, sorry. 7, the deck of cards, I'll probably make a separate video on for those of you who aren't familiar with it. But here's some more definitions. An event consists of the outcomes of a probability experiment. An event with one outcome, like rolling one die, is what we call a simple event. An event that consists of more than two outcomes, meaning, now, don't confuse this, okay? If you're doing one event, so you could have more than one possible outcome that fits this situation. That's what this compound event means. You're rolling a die, a single die, you're only going to have one result, aren't you? Right? Like 6 or 3. But you have, if you say, roll a die and get a number less than 4. Well, the die has outcomes 1 through 6. So the numbers less than 4 would be 1, 2, or 3. You have 3 possible outcomes that would fit that. All right. Now I'm going to come back to the types of probability in a second. But one of the things about probability, which I think comes later in this, in the slide presentation, I don't see it on here just yet. I'm going to scroll through for a minute and see if it's here. But here it is. If you look at slide number 20, and there's a reason why it's here and not further up, but probability rules. We have some notation for this. So if we have an event and it's an impossible event, for example, roll a fair die and get a number larger than 6. A single fair die number larger than 6. That's not possible. That probability is 0, okay? If I say an event is certain, then the probability of the event is equal to 1. Probabilities are always positive. Probabilities are always positive or 0, okay? Or 0. Remember, 0 is impossible. 1 is absolutely certain. There's no way for it not to happen. So let me take a digression here for the next part of this question. All right. Let me go in and share the homework here. My mouse was having a bit of an issue responding to me. Okay, so here's where we are. Okay, so we've talked about an event. We've talked about the outcome versus an event. What is the range of values for the probability of an event? That's on slide number 20. Okay. It ranges from 0 for impossible to 1 for absolutely certain, okay? If an event cannot happen, we assign 0. So what is the range of the values of the probability of an event? Okay, so here you would say question 3, okay? This is question 3 on the homework. The range of the values of the probability of an event is, and you can write the statement if you'd like. This is, we're going to engage our math skills. 0 is less than or equal to the probability, which we typically denote with a capital P, less than or equal. Oops, let me fix that. Looks like an L sign. Whoops. Undo that. I didn't mean to erase the whole. Okay. This is less than or equal to. Let me angle it this way. There we go. Less than or equal to 1. Okay. Remember, 0 means the 0 means the event is impossible. 1 means the event is absolutely certain. Now, sometimes this trips students up. They're not sure exactly what this means. So let me give you some examples, okay? Examples, and there are as many examples of impossible events as there are students to think them up. But examples of impossible events would be something like rolling a single fair die, and getting a number larger than 6. Okay, another impossible event, flipping a coin and getting both heads and tails. This is impossible. You can't have both at the same time. Here's another example of an impossible event. Selecting a person at random who is a parent with no children. Okay, now your children may be grown, they may be passed away, but if you're a parent, by definition, you have children. Okay, you can't be a person who is a parent with no children. That would be impossible. This third one would be an example of a certain event. Okay, so these are impossible events. Let me put the certain events down here. If I have examples of absolutely certain events, okay, absolutely certain events. Well, rolling a single fair die, oops, and getting a number less than 10. That's absolutely certain. You have to get a number less than 10. Here's another example. If you said, we're going to select a book at random and find the page number to be, let me move this up so we can see it in the screen, to be even or odd. So the page number would have to be even or odd. If you don't know the difference between even and odd numbers, even numbers are divisible by 2. So 0, 2, 4, 6, 8, 10, all of those are even numbers. Odd numbers are not. So they're like 1, 3, 5, 7. So your page number has to be either even or odd. Those are examples of absolutely certain events. Okay. So we have a lot more to talk about with sample spaces, with even or odd events, with a lot of these things. But I want to give you just a little bit more guidance here with a couple of these problems. I want to set you up with, okay, number 5 is probably pretty easy. If you've ever watched the weather, you probably have gauged in this. If the probability that it will rain tomorrow is 0.2, what is the probability that it won't rain tomorrow? And would you recommend taking an umbrella? Well, remember that the sample space, okay, all the probabilities in our sample space have to add up to 1, okay? Now, that doesn't mean that everything is certain. It means that if we add up all the probabilities that we have, they add up to 1. So here's what's going on here. This is actually easy. Don't overthink it. But in terms of the question, here's what's going on here. We either have, in the case of number 5, we have 2 possible outcomes, okay? So our experiment for number 5, to wrap up how this works, our experiment for number 5 is make a determination about the weather tomorrow, essentially. Now, whether we use a computer program, whatever it is, that's our experiment. Our outcomes, so our sample space, these outcomes, remember, are the ones that are possible, are either one of 2 outcomes. We either have rain tomorrow or no rain tomorrow, something else. So it's either going to rain or it's not going to rain. There is no, we're not talking about what other kind of weather we could have. We could have snow, we could have sleet, we could have blazing sun, depending on where we are and what the temperature is. But in this case, we don't care what the weather is. It's just a matter of either rain or not, okay? Now, like I said, there are plenty of problems where this is more complicated, but we have 2 outcomes in this sample space, and they've assigned a probability to each one. So the probability of rain is 0.2, okay? The probability then of no rain is what we want to find out. Now, most of you have probably figured this out already, but let me show you how this works using the probability rules. We want to know what the probability of no rain is. Okay. Because there's only two outcomes in the sample space, this is pretty easy. So here, we're going to say this. We need to know something else about probability. The sum of all the possible probabilities in a sample space is equal to 1. Now, that means if you add everything up, I could have 5 impossible events and 1 certain event. But anyhow, any way I do it, if I have a sample space, the sum should equal 1. So here's what's going on here. We have 2 events. So what we can say is this. The probability of rain tomorrow plus the probability of no rain tomorrow equals 1, because the likelihood of all the events in a sample space has to equal 1, okay? So what do we know the probability that rain tomorrow is? Well, they gave it to us, it's 0.2, right? We don't know what the probability of no rain tomorrow is. Let's call it X, just for the sake of example, right? That's equal to 1. So that means X is equal to 1 minus 0.2, which is 0.8. So actually, instead of calling it X, let me call it E for event. Okay, so E, probability of, let me fix this line. Give me a minute here. Just so it'll be consistent with this. So here, this is going to be 0.2 plus, I'm going to write it like this, plus the probability of E is equal to 1, right? And so here, I'm going to sneak it in. So we get 0.8 for that, okay? 1 minus 0.2 is 0.8. And so the probability of the event is equal to 0.8, okay? So I can write that up here, that, come on, there we go, 0.8. So the probability that it won't rain is 80%. Probably already figured that out. That's how the basics of this particular section work. Now, there are some card probabilities in the first 10. You do have the sample space for a deck of cards. I will come back and talk about those things in more detail. But for now, I'm going to go ahead and wrap up this video. And I'm going to hope that it has been helpful to you. And I will see you in my next video. Take care, everyone. I hope you're doing well. Bye for now.